For decades, astronomers have been keeping a careful eye on one of the brightest and most unpredictable stars in the night sky, Betelgeuse, the colossal red supergiant perched on the shoulder of Orion. Scientists have long suspected its end was approaching. The only problem? No one could agree on when the cosmic curtain would finally fall. Now, Webb may have captured something extraordinary, something astronomers once wondered if humanity would ever witness at all. The first signs of Betelgeuse beginning to tear itself apart, a stellar death in progress, a titanic shockwave rippling through space, a front-row seat to the raw, unfiltered power of the universe. And this isn't just another distant cosmic event tucked away in some far-off galaxy. This is a once-in-a-lifetime moment, the closest supernova humanity may ever observe in such detail. And what Webb has revealed is already forcing scientists to rethink what they thought they knew. Betelgeuse, sitting about 642 light-years away in the Orion constellation, is anything but an ordinary star. It's a red supergiant so enormous that if it replaced our Sun, its outer layers would stretch far beyond Mars. With more than 20 times the Sun's mass and roughly 700 times its diameter, Betelgeuse has lived a fast, dramatic life. And like many cosmic celebrities, it's been a little unstable. For decades, astronomers watched it swell, dim, brighten again, and occasionally throw off giant clouds of gas, like a stellar diva having a very public meltdown. Then came 2019. Almost overnight, Betelgeuse dimmed dramatically, triggering headlines, late-night debates among astronomers, and more than a few excited whispers. Was this it? Was the star finally going supernova? As it turned out, the star recovered. But the episode revealed just how fragile Betelgeuse had become. Now, with the extraordinary sensitivity of the Webb telescope, the mystery has only deepened. For the first time, scientists are seeing real-time signs of a massive star entering the final stages of collapse. Immense energy bursts, surface convection shifting like boiling magma, magnetic fields twisting themselves into chaotic knots. Betelgeuse isn't simply fading away, it's transforming, right before our eyes. For months, Webb has been staring directly at the star using its powerful infrared instruments, peering through layers of gas and dust that earlier telescopes could never penetrate. And the new data has left astronomers stunned. On Betelgeuse's surface, gigantic convective bubbles, each roughly the size of Jupiter, rise and burst like cosmic lava lamps. Massive plumes of superheated gas are blasting outward into space at incredible speeds. Hidden inside the star's spectral fingerprints, researchers have even detected what appears to be a shockwave propagating through its outer layers. For the first time in history, astronomers are witnessing the physics of a star actively tearing itself apart. This isn't a computer simulation or a theoretical model. It's the real-time anatomy of a supernova. And it's happening only 642 light-years away. In cosmic terms, that's practically next door. Most supernovae we observe occur in distant galaxies, appearing as faint flashes of light across unimaginable distances. Betelgeuse, however, is close enough that when it finally detonates fully, the explosion could shine brighter than the full moon, and may even be visible during the daytime sky. But the brightness isn't the most exciting part. Its proximity gives scientists a once-in-a-generation opportunity to study stellar death up close. How the core collapses, how shockwaves ripple outward, and how heavy elements like carbon and oxygen are forged in the inferno. In other words, we're watching the cosmic factory that creates the ingredients of life. The atoms in your bones, the oxygen you breathe, the iron in your blood, many of them were forged in explosions like this. In a strange way, observing Betelgeuse is like watching our own origin story play backward. The coming explosion isn't just a spectacle, it's a key that unlocks the deeper mechanics of the universe, how galaxies evolve, how planetary systems form, and how matter cycles through cosmic time. Through Webb's instruments, astronomers can now model the final stages of stellar evolution with a level of precision that was impossible even a decade ago. They may even learn to recognize the warning signs of future supernovae long before they occur. Moments like this blur the line between science and revelation. Humanity looking into the abyss of space and seeing something profound stare back. When Betelgeuse finally detonates, the event won't stay confined to the star itself. The explosion will send powerful shockwaves racing across light years, disturbing the surrounding interstellar medium. Webb has already begun detecting the earliest ripples, streams of energetic particles racing outward, heating nearby gas clouds and reshaping the star's surrounding halo of dust. But there may be an even stranger consequence, a gravitational one. The violent collapse of Betelgeuse's core could have generated gravitational waves, tiny ripples in space-time itself. If scientists manage to link those signals to this event, it would mark the first time a visible supernova has been directly tied to gravitational wave data. That would open an entirely new window into how matter, light, and space-time interact. And as the star collapses, another mystery emerges. What exactly will be left behind? A neutron star? A black hole? Or something we've never seen before? Webb's data hints that the collapse may not be perfectly symmetrical. Magnetic disruptions, plasma voids, and strange fallback patterns suggest some material may be pulled back inward rather than blasted into space. Some astrophysicists have even begun speculating about a transitional object, something between a neutron star and a black hole. A strange hybrid predicted by theory but never directly observed. If Webb has truly captured the birth of such an object, it would mark the discovery of an entirely new class of cosmic phenomenon. Naturally, when people hear that a massive star only 642 light-years away is about to explode, one question tends to come up. Are we in danger? The short answer, no. Betelgeuse is far too distant to harm Earth. The longer answer, however, is a bit more complicated. The explosion will unleash vast waves of high-energy particles, gamma radiation, and expanding electromagnetic fronts. While these won't threaten our planet, they could disturb nearby cosmic dust clouds, influence surrounding star systems, and slightly alter how light from distant regions of space reaches us. Astronomers are carefully monitoring the expanding radiation front to understand how this event may reshape our galactic neighborhood. Because even if we're safe, the explosion could subtly change the cosmic scenery we observe for centuries to come. Betelgeuse is ancient, massive, and incredibly powerful, yet even stars don't live forever. Its approaching death reminds us that nothing in the universe, not even the brightest lights in our sky, lasts indefinitely. But what Webb captured isn't just the end of a star. It's a glimpse into the cycle of cosmic renewal. When Betelgeuse explodes, it will scatter elements like carbon, oxygen, and iron into space, along with rarer ones such as technetium and yttrium, forged in extreme stellar conditions. These elements will drift through the galaxy, eventually forming new stars, planets, and perhaps even life. In other words, what looks like destruction is actually creation in disguise. By studying the chemical fingerprints of this explosion, scientists can trace the journey of matter, from dying stars to cosmic dust to planets, and ultimately to us. Webb isn't just observing a spectacular event, it's decoding the chemical story of how life becomes possible. Soon, the familiar red glow in Orion's shoulder will fade, replaced by an expanding cloud of glowing debris. But Betelgeuse's death will not be meaningless. It's a gift of knowledge, and a reminder that even our own sun will one day face its final chapter. Because without supernovae, there are no planets, no oceans, no life. And thanks to the James Webb Space Telescope, humanity can now watch that cycle unfold, from fiery collapse to the seeds of creation. Out in the darkness, 642 light-years away, a star has ended its life. Not quietly, but with a brilliant final roar that traveled across the cosmos until it reached us. And for the first time, we didn't just see it, we began to understand it. So now the question is, what other secrets is the universe preparing to reveal? And are we ready to see them? Let us know in the comments. Could this be the most important stellar event of our generation? And what cosmic mystery should the James Webb Telescope explore next? Subscribe and turn on notifications, because this isn't the end, It's the beginning of everything that comes after the stars.